5G networks have been commercialized in large scale. No matter how far away we travel, our phones can always get 5G signals. We are individual users. The service to us is called 2C traffic. Compared with traditional 4G networks, one characteristic of 5G network is that it has a lot of industry users, which means there will be a lot of 2B traffic. For this reason, as far as the traffic diversity is concerned, 5G network is much more complicated than the 4G network. The more diversified of the 2B and 2C traffic, the higher the requirement to the high efficient and precise usage of a network resource. Only by being precise can we guarantee 5G user experience, and only by being efficient can we unlock the potential of 5G network. The mobile network has been researched and developed for many years. A set of KPI index has been accumulated to monitor the quality of the network, and we can configure and optimize the network according to the results. For example, throughput, latency, jitter, call drop rate, etc. But here the problem comes. These traditional KPI are all from the perspective of the entire network, which means the network service quality is evaluated from network-centered view. For the actual needs and actual experience of different users, there's much less concern. For individual users, the common problem is lack of guarantee. For example, if a guy is just sending short messages and photos to his girlfriend, even if the network can provide throughput far exceeding the actual needs, the user will not have any special feeling. Imagine another guy is having an HD video call with his girlfriend at the same time. If the video resolution drops due to poor network conditions, or there's a freeze of the image, then user complaints will be triggered. For these two services with very different resource requirements, the network is likely to treat them equally. Due to the lack of guarantee of the second user, it is easy to cause complaints about the quality of the network and lead to the loss of users. For industry users, the network strategy is just on the opposite, and the common problem is over-guarantee. Industry users generally have much higher requirements for service quality, so in a conservative way, network resource is allocated to be much more than the practical needs, which results in the waste of network resources and insufficient system service capacity, thus limiting the profitability of the network. So, how to solve these problems? How to change the resource allocation strategy from a relatively rough network-centric to a user-centric precise service paradigm? This depends on a more reasonable combination and configuration of network resources, which is often referred to as orchestration. We can think about it from two perspectives: the network and the user. User orchestration. User orchestration is to identify the actual needs of user services and intelligently select the most appropriate configuration for user services based on the network service capabilities. Precise identification of user requirements can be achieved by learning the characteristic of stream and packet, combined with the features such as slice ID, service type, and service strategy. Precise prediction of network service capabilities can be achieved through the modeling of different scenarios, combined with the interaction of real-time information such as network load and learning from accumulated data such as spatial coverage and spectrum efficiency. In this way, we can guide users to the most suitable resource layer according to the actual needs of the user's traffic, and satisfy the user experience with the most reasonable resource allocation. In short, good user experience with the least network resources. Network orchestration. Network orchestration is to reasonably arrange resources at the network level to ensure that as many users as possible have a high-quality experience. For the physical resources of the network, including spectrum, carrier, beam, and frame structure, we can calculate in advance how many combinations of them can be used. At the same time, make accurate predictions for the future traffic demand of the network. In this way, the most reasonable network resource allocation strategy can be adaptively selected from the pre-prepared combinations according to the practical need of the traffic. So the maximum capability of network service can be obtained. User orchestration and network orchestration complement each other. With them, the network can understand better of itself and its users, which will change the resource allocation strategy from network-centric to user-centric. So the network can not only take care of each user better, but also serve more users. The network value and economic benefits of 5G will also be maximized.